There, Mr. Sutton here with the Algebra 2 Honors 2-3 Part 2 homework solutions on graphing and applications of parabolas in focused directrix form. For this first problem, they want us to graph this parabola showing the focus and the directrix. So let me start by getting the vertex. So there's an invisible y minus 0 in there, so that gives us 0 for the y value of the vertex. There's an invisible plus 0 out here, so that's 0 for the x value. So 0, 0 is our vertex. We also need to find the p-value. We can do that by setting 1 over 4p equal to this negative 1 over 20. If I cross multiply, that gives me 4p equals negative 20, which leads me to the conclusion that p equals negative 5. Now I can use this p-value to get my focus and my directrix. To get the focus, I just have to add p to the vertex, and I'm going to add it actually to the x value of the vertex because this is an x equals type of equation, so it's a left-right equation. Only the x values are changing. So we have 0 plus negative 5 or 0 minus 5 for the x value of the focus. That's just negative 5 comma 0. Now to get the directrix, I just have to do the vertex minus the p-value. So we're going to end up with also an x equals for the directrix because our original equation was x equals. So we have x equals 0 plus 5 or minus negative 5, which comes out to 5. And now it's time to graph all this. So here's my vertex at 0, 0. Here is my focus at negative 5 comma 0. And here is my directrix at x equals 5. It's a line going through x equals 5. Now I need two more points that are the same distance from the focus and the directrix. So let me start at the focus. The focus, you'll notice, is 10 units away from the directrix. So we need to count off 10 units in both directions. So let me just go up first. So we got 2, 4, 6, 8, 10 right there. And going down now, we have 2, 4, 6, 8, and 10. And I can just draw the parabola through those 3 points. To graph this next parabola here, let me get my vertex. We have an invisible x minus 0 and also an invisible plus 0, so our vertex is 0, 0. And for the p-value, I'm going to set 1 over 4p equal to negative 1 over 12, the a value there. If I cross multiply, I see that 4p equals negative 12, which means that p equals negative 3. To get my focus and directrix, I have to add and subtract this p-value to my vertex. And I'm going to be playing around with the y value of the vertex because this is a y equals. I mean, it's the same x and y value, but just for accuracy's sake. So my focus then is going to be 0 comma 0 plus negative 3, which just means 0 comma negative 3. For the directrix, I'm going to have a y equals type of equation to match the y equals thing that I started with here. And it's going to be y equals 0 minus negative 3. Or just simply y equals 3. Now I have enough information to graph this. I have my vertex at 0, 0 right there. And for the focus, we are at 0, negative 3 down here. And finally, for the directrix, we have y equals 3, a horizontal line through 3, going this way. One more thing I need is, actually two more things. I need two more points that are the same distance from the focus and directrix. The focus is 6 away from the directrix, so if I start at the focus and count off 6 squares in each direction, I'll get to the 2 points that I need. Now, I do need to be a little bit careful here. I mean, if you looked closely, you notice that my vertical grid lines are going by 1s, but my horizontals are going by 2s, and I did that so that I could fit everything. But if I'm counting off 6 spaces from the focus, that's actually 1, 2, 3 squares. That's a total of 6 on the x-axis. So that is one of my points. And my other is going to be 6 in the other direction. There we go. And then draw the line, or the parabola going through those 3 points. For this problem, I have to graph this parabola showing focus and directrix, Before I can do that, though, I need to isolate this linear term. So let me add y to the other side. So I have y equals 8x squared, and that just puts me in a form that I can actually graph things in the form that I'm used to for these. All right, so for my vertex, there's an invisible minus 0 in that x squared kind of contraption there. So we have 0 for the x, and an invisible plus 0 out here gives us 0 for the y of the vertex. For my p-value, I can figure that out by setting 1 over 4p equal to 8. If I cross multiply here, I see that 4p equals 1 over 8. And if I divide by 4, we have p equals 1 over, this is really like multiplying by 1/4, so 1 over 32. To get my focus, I need to add my p-value to the vertex, and I'm adding it to the y-value because this is a y equals type of equation. So we have 0, 0 plus 1 over 32, or just 0, 1 over 32. To get the directrix, it's going to be a y equals line because, again, we started with y equals. And it's going to be y equals the vertex y value minus the p-value. So 0 minus 1 over 32. So y equals negative 1 over 32 is my directrix. All right, let's go ahead and graph all this. My vertex is 0, 0, so right there. And now for the focus, that's going to be 1 over 32 up. Now, the way that I set this up here, I tried to make it go by 1/16 in Desmos, but it gave me a decimal. This is actually 1 over 16. So this right here, 2 grid lines up, half that distance is 1 over 32. And then y equals negative 1 over 32 is going to be right down here. So my heart was in the right place, but it might be tough to interpret those numbers if you don't know your fractions. Now I need 2 other points that are the same distance from the focus and the directrix. So starting at the focus, which is already 4 away from the directrix, I just need to count 1, 2, 3, 4 in one direction and 1, 2, 3, 4 in the other direction. And that gives me some points that I can now draw my parabola through. For this problem, they want me to identify the vertex, focus, and directrix of this parabola. For the vertex, since this is essentially in vertex form, I can just take the 3 and the 2 right out of here and have 3, 2 for my vertex, just remembering that this inside stuff is opposite from what it appears to be. Now, to get the focus and directrix from this, I need the p-value. I can get that by setting 1 over 4p equal to this 1 over 8 term out in front. So cross multiplying, 4p equals 8. So then p equals 2. Now to get the focus, I just have to add my p-value to the vertex. And I'm going to add it to the y-value of the vertex because this is a y equals parabola here, so we're only affecting the y-values. So my focus is going to be 3, the x doesn't change, 3, 2 plus 2, which is 3, 4. For the directrix, my line equation is going to be a y equals type because it matches the original equation. And it's going to be y equals the vertex y value minus the p value. So y equals 2 minus 2, which is y equals 0. And that's everything they asked for. For this one, they want the vertex, focus, and directrix of the parabola, although we don't need to graph it. The vertex is the easiest part. I'll just pick it right out of here. This plus 3 inside means we have a minus 3 for the x of the vertex. Minus 5 outside means we have minus 5 for that y value of the vertex. For the p-value, which we need to get the focus and the directrix, we're going to set 1 over 4p equal to the invisible 1 out here. So that one's a little tricky because of that invisible coefficient. Cross multiplying, we have 4p equals, well, just 1. So that means p equals 1 over 4. Cool. So to get the focus, I have to add my p-value to the vertex. Since this is a y equals parabola, I'm just going to add it to the y value of the vertex. So our focus is going to be negative 3, negative 5 plus 1/4. I could turn that into another fraction, but I'm lazy, so I'm just going to call this negative 3, negative 4.75. This is like having a plus 0.25. So that gives me one representation of my focus, but you could use a fraction if you wanted for this. For the directrix, I just have to subtract p from this negative 5 in the vertex. And my line equation is going to be y equals, because we have a y equals parabola. So I'm going to write for the directrix y equals negative 5 minus 1/4, which I can turn into negative 5 and 1/4 or negative 5.25. Any of those is sufficient. For this one, getting the vertex, focus, and directrix of the parabola, let me start by getting my vertex. Now this is a little bit tricky because this is one of those x equals sideways parabolas. So this inside stuff here is actually giving me the y value of my vertex, which it's opposite from what it appears because it's inside. So that's a negative 4 for the y value. And this plus 2 out here is a positive 2 for the x value. So 2 comma negative 4, that's our starting point. Now I need the p-value in order to get the focus and directrix. So I'm going to set 1 over 4p equal to negative 3. Cross multiplying, we have 4p equals negative 1/3. And then dividing by 4 or multiplying by 1/4, p is going to be negative 1 over 12. Okay, let's get the focus now. I can get that by adding the p-value to the vertex. And we're going to add it to the x value of the vertex because this is an x equals equation. So I have 2 plus negative 1/12 comma negative 4. This is really like having 24/12 plus negative 1/12. That's 23/12 comma negative 4. So that'll give me my focus. For the directrix, I have a line with an equation of x equals, because we have x equals for the original parabola. And it's going to be x equals my vertex x value minus this p value. So x equals 2 minus negative 1/12. This is like having 24/12 plus a 12th, which is 25/12. So there we are. For our final boss battle on this homework, we have some scientists studying dolphin echolocation, simulating a bottlenose dolphin's clicking sounds with some computer models. The sounds originate at the focus. Here's the focus of a parabolic reflector. Okay. And this parabola represents a cross-section of the reflector with a focal length of 1.3 inches. So it's 1.3 inches from the vertex to the focus. That's good to know. We also have an aperture width, that's this width right here, of 8 inches. It's not immediately apparent how that's going to help us, but it will later, trust me. They want us to write an equation of the parabola and then find the depth of the reflector. Since this is a left-right parabola, I'm going to go with an x equals 1 over 4p y minus k squared plus h kind of deal. And that means we need to get the vertex, which is the h and the k, and we also need the p-value. So the vertex is pretty straightforward. We're going to call the vertex 0, 0 because this parabola is going through this 0, 0 spot right here. So that was pretty easy. For the p-value, we just have to find the distance from the vertex to this focus. That's just going to be 1.3 minus 0, which is just 1.3. So plugging that in, we have 1 over 4 times 1.3. And the vertex is 0 and 0, so the k and the h are 0. So this is all really just going to be a y squared when we plug in 0 and 0 and simplify it all. And then this comes out to 1 over, I guess this would be 5.2 y squared. You could make that a fraction if you wanted to, but we're not, I mean a less decimally fraction, but we're not going to worry about that. This works. We do need to find the depth of the reflector though. So in order to figure that out, we're essentially asking, what is the distance from the y-axis to the highest point of this parabola when it describes this aperture opening here. So to get that value, we basically need to take half the aperture. We need the distance from the center of this thing to one of the outsides. So for the y value we're plugging in, we're going to take half of 8, which is 4. So we're going to do x equals 1 over 5.2 times 4 squared. And for that, I'm going to go to Desmos. So let me do my fraction, 1 over 5.2, and then we'll multiply that by 4 squared. And that comes out to about 3.077. We can round it off here to 3.08, and that's going to be in inches.